Creating recurring meetings is one of the most difficult features that you can build in an application which is meant for managing meetings. And that's for a reason, because recurring meetings involve exceptions, a lot of exceptions. And not just that, there are things around data modeling that we need to consider, things around daylight savings time, impossible dates, and a lot of scenarios that are needed to be considered while building such an application. So if you are a college student or just graduated the college and want to know about what complexities that go inside of this, then this video is perfect for you. And in the next few minutes, I'm going to dive deep into each of these complexities. The goal is to keep things as simple as possible. There are two models of handling the writes that has been described here. One is the expansion based and one is the compression based. What happens in the expansion based models is that for every event of the series, we store an entry into the database. Like for on X day, on Y day, on Z day, there is one row. And then here we store the rule into the database, which goes something like start at 9 a.m. then, and the rule is frequency is weekly, by day is Monday. So this is the rule that is stored in the database and it is inferred in the future processes. But here the problem is that the infinite write problem. What it means is that if you want to set an infinite series, then you basically cannot do it, because of course you cannot insert infinite rows into the database. But if you arbitrarily cap it, let's say, okay, I will want to cap it to 2 years, and then when the 2 years finish, then you have to maintain a job kind of thing that is looking at this series particularly and telling you that, oh, this series is about to expire, then I need to insert more events into the database, which again might be not so nice, if I may. I mean, not so nice in the sense that you have to maintain a burden of this job. But here you don't have any such problem. Like, you can have infinite series without any problem because you're not inserting anything into the DB. But that's just first thing, right? The creation of infinite. Okay, the database doesn't know where the meetings is next. I mean, there are going to be challenges, but at least you can have the infinite meetings via this approach. So the next problem that we have is on the compression and expansion based approaches, is about the reads part of the things. So the expansion based, you can basically run a simple query. If a user goes and wants to check his meetings between like 31st March and 30th April, then they can simply run a query between X to Y to fetch all the meetings that are there, because you have specific entries for each of the meeting. But here you need to have a special, which is, let's say, a special algorithm that needs to infer the rule. And then, like, okay, the rule that we saw before was this kind of thing. So now you need to have an algorithm that understands the rule and the query, and then it basically generates those events in between them, then returns, which can be computationally expensive. So the next problem that we need to handle is the exceptions. The first problem that we are having here is that, suppose you inserted on, you have your series on every Monday, which is 7th, 14th, 21st, and 28th, right? So on 14th, you realize, oh, it's a public holiday. So the user wants to update this meeting to 15th, right? But now you also want to ensure that any changes that are applied to this series are also applied to the 15th. So you cannot just change the date of this particular meeting in the database saying, oh yeah, I just keep this meeting out of the series. So basically it's still a part of series, but it's an exception that it's going to be on the 15th. And in the compression based, this was for the expansion based approach, right? So in the compression based approach, it's even difficult, because how do you kind of even keep a track of, like, the rule we saw, right? The rule was this kind of rule over here. Now in this rule, how do you even say that on the 14th of January of 2027, I don't want to keep this meeting on 14th, but rather keep on 15th? So you will have to have some other complex approach over here again to be able to handle this kind of scenarios. My eraser just doesn't want to work properly. But yeah, you want to make changes to the future ones, which are the exceptions, the 15th January that we talked about. But there is another problem, is that you also want to keep your old meetings that happened on the same schedule, right? So you don't want to change the old meetings because they have already happened. So you need to also take care of not updating. Actually, the expansion, yeah, the expansion based model is a trouble because you have this date, the exception that we had discussed before, and the compression based model is basically you have to somehow again fit the things into the rule, right? So fitting the things into the rule is, I think, the biggest problem that's coming out on the compression based approach. So maybe you split the rule. So maybe you split the rule and then you start to create some things, right? For the upcoming series, you want to change it to this. So, and also here you want to keep a track of the exceptions that were created. So this is another problem, right? So what is the solution over here? Let's understand about this. So to solve the problems that we have discussed before, there is a genius strategy that has been mentioned here about, which is very, very simple to understand. Let me try to draw it for you. So what happens is that we have three tables in here. One is the rule table in which we are storing the rules just like we discussed before. So the ID, we give each series an ID, and then we have the rule and we have the metadata for the rule, let's say, which will be helpful in deciding some things later on. Then we have let's give this a green color, exceptions table, in which one of exceptions for a particular date. For example, here they are talking about, modifying the series, modifying the event of 16th of February, right? So what would be stored in here is that the ID of the series, and the original date and the update date kind of thing, right? So any metadata basically which can highlight that, oh, the 16th Feb event was modified to be happening on the 17th Feb due to any exceptions kind of thing. And then the must piece is this third table that we are seeing over here, the instances table, in which there is a job that is reading from both of these two tables on the scheduled basis, which is reading from both of these two tables and creating a new table which has the actual instances that are happening. So this job reads the rules, okay, that I found a rule for a series 101, which means that I need to generate the meetings on 7th, 14th and 21st. But then it realizes, okay, there are exceptions between, it reads the exceptions and then it says 14th doesn't work, so I need to create for the 15th. So it goes in over here. And one important point is when a user tries to make a change to these things, this scheduler job, so if it tries to make a change to the series, then the scheduler again runs from that particular date. So all the future events from this materialized view table are removed. The scheduler runs again, taking the exceptions and all these kind of things, whatever have been created, and rebuilds this table essentially. So that's what has been kind of mentioned here, disposable table only for the use. So you have the rule table exceptions, which generates the actual rolling window for -6 months to +2 years. Yeah, this table also keeps the historical records for fetching the historic. This table also keeps the historical records for fetching the old records for a particular user. So your reads are very quick. You handle the exceptions by fetching from this table, and yeah, you can quickly create the writes and everything. So if we look at these problems that we discussed before, we solved the problem of infinite writes because this job is, yeah, I mean, it's using the compression model based approach somehow, the solution from the compression based model approach to build infinite events. So we didn't have to store the infinite events into the DB. Reads are fetched from this particular table. Then we have the exceptions, which handled by the job itself, the scheduler job that we talked about. And then we have the series update, which again are handled by this table and the job essentially. So you solve kind of all the problems. So now we will move to the next problem.